Now we're going to take a look at what happens when we have triangles that are not right-angled triangles. Well, when we have triangles that are not right-angled triangles, what we do is we use the sine law or the cosine law. And we use the sine law or the cosine law based on what we're given. There are four scenarios we could have. Two of them are sine law, two of them are cosine law. When you are given two angles and any side length, you're going to use the sine law. When you are given two sides and an angle that is not contained, so what is a contained angle? This angle B is contained by side C and side A. Side C and side A contain or make up angle B. Angles A and C are not contained by sides A and C. Angle B is contained by side A and C. So when you have two sides and an angle opposite one of those sides, in other words, not contained by it, two sides in a non-contained angle, use the sine law. You will use the cosine law when you have, when you have two sides and the contained angle, the angle is in between the two given sides, or when you're given the measure of all three sides. So now let's take a look at what the sine law is, what the cosine law is, and how we use them. So the sine law, I'm not going to get into how we derive it in the proof. You're not going to have to prove it. So here, the sine law is the sine of A over A equals a sine of B over B equals a sine of C over C. And of course, big letters are angles and small letters are sides. And just like 1 over 2 equals 2 over 4 equals 3 over 6, we know that if you flip it all, 3 over 6 equals 4 over 2 equals 2 over 1. That's also true. So likewise, you can use this or you can flip it. What you will find is once you set up your question and you do the arithmetic to solve it, it's much easier to solve if you put whatever you're looking for, the unknown, in the numerator. Okay? Now, here is the cosine law. The cosine law is right here. The cosine law is, and of course, these A, B, C's, and so on, that's angle A, angle B, angle C, and that's supposed to be a big C. And then these small letters are the side lengths. So it kind of looks like Pythagorean theorem when you just look at this part, right? You've got here A squared equals B squared plus C squared and so on. So if you're looking for side A or angle A, you will use this. If you're looking for side B or angle B, you'll use that, and side C and angle C. So when you are writing this up, this is how I memorize this. I just say, okay, this is what I'm looking for. I'm looking for angle A or side A, so it'll be A squared equals. I write the other two like Pythagorean theorem. And then I say I'm going to minus the two that are on this side. So minus 2, B and C. And then the cos of, and these two are the same. And that's it. So if you're looking for B, side, or angle, you'll do B squared equals the other two squared minus 2 times these two, cos of whatever the first one was. If you want, you can solve all of them with these formulas. However, some people like to, if you rearrange this, you can also get these formulas, and some people like to memorize them. I never bothered to. I want to memorize as little as possible and understand as much as possible. So I just use those. Okay? So now that we've seen what cos and sine law formulas look like, let's try some questions. And then we're done our trigonometry chapter. So here we've got solve. Solve means always find all angles and all sides. Okay, and again, if you write it out 1, 2, 3, 4, 5, A, B, C, you're going to find it's really easy to see what you need to find, what you already have, and all that jazz. So A is 110 degrees, B is 30 degrees, C is 40 degrees. Side A is 25 meters. Side B is going to be something meters, and side C is going to be something meters. So let's see here. If I know that sine law, as you can see, sine law is simpler than cosine law. So whenever if you have a choice, because if you're given different scenarios, like if you're given two sides in a non-contained angle, but you're also given three side lengths, you can say, oh, I can use cosine law or sine law. Sometimes you're given only a small bit of information, so you have to use only what you're given, which means that you have to use only the sine law or only the cosine law. Okay, so here you go. Let's find side B. So to find side B, we're going to say, okay, I've been given two angles and any old side. So when you're given two angles and any side, you get to use the sine law. So I'm just going to say, okay, if I'm looking for side lengths, I'm going to put the side lengths in the numerator because, as I said, that's easier. So I'm going to do A over sine A equals B over sine B equals C over sine C. So A is 25, sine A is sine of 110, B I don't know, sine B is sine 30, C I don't know, and sine C is sine 40 degrees. So I know if I take these two and put them into a proportion, I can cross multiply and solve. And then if I take these two and put them in a proportion, then I can cross multiply and solve also. So let's do that. First I'm going to put the first two, 25 over sine 110 equals B over sine 30. When I cross multiply and I just bring this over on the cross, I can do 25 sine 30 over sine 110 equals B. So again, all I did was I brought this up, plunked it over there, and left this as B over 1 or B. So now I have to put this in my calculator. You're probably faster than me, but give it a go. See what if you find when you use your calculator that you get what I got. So 30 sine, 1 second. So what's this? 110 sine. So I got 12.98-ish. So B equals about 12.982. And let's see here. Does it tell me how many decimals? So it doesn't tell me how many decimals. So what I say is either the best thing to do is whatever they gave you to follow suit. So if they give you to 1 decimal place, do 1 decimal place. Here, they've got you rounded off to the nearest whole number. So round off to the nearest whole number. 12.982 is 13. So now we've got two sides, this and this. Can we use Pythagorean theorem to find the third side the way that we did with the other ones? No, because this is not a right angled triangle. So we have to let these two equal and do what we just did here. So we've got 25 over sine 110 equals C over sine 40. Then we've got C equals 25 sine 40 over sine 110. And now let's plug this into our calculator. Okay. And I've got about just over 17. So I'm going to make that 17, and there I'm done. Okay? So now let's try another one. Before we get into word problems, let's try, okay, well, let's try this one. Here, we know that when we are given two sides and a contained angle, and I just remember contained starts with C and cos starts with C, so we know we're going to use the cosine law. So this is side X, or angle X. So let's call this Y and this Z. So I'm going to write out the cosine formula, which is if we're looking for X, then we know we're going to have X squared. And then we're going to do equals Y squared plus Z squared minus two of these, 2YZ cos, whatever that is. And we make it exaggerated so we know that's an angle. So let me see what I'm going to plug in here. X I don't know. Y is 11. Z is 8 minus 2, 11, 8 cos of 70. So long, yes. Complicated? Not really. Right? Don't freak yourself out. This is not so complicated. You're just subbing in what you know. You know that if that's angle Y, that's side Y. If that's angle Z, that's side Z. If that's angle X, that's side X. So now let's plug this all in. X squared equals 121. Of course, you know your times table, so you know that. And then this whole 2 times this times this times this negative is so just over 60, so minus 60.195 more, but anyhow. And then you're going to do, let's see here. Wait a second, I just made a mistake. Here we go. We've got 121 plus 64 minus 60.195-ish is equal to this. But remember, this is not what X is. This is what X squared is. So now we need to take the square root of this. So X is about, actually this should be a dot also because this was rounded off, about 11. 11.1716, blah, blah. So find X, we did that. Here, solve the triangle. We're given all side lengths. We're going to sub in and find the angles.